Okay, for question 18, yeah, so this is the question a rocket launches. When you read the stem of the question, it is probably a section B question, right? So the stem, they will give you information they need to extract from and understand. So a key piece of information here is that stage 1 carries the fuel, so this is stage 1. The whole question is more or less about stage 1, which is referring to this part of the rocket. It carries the fuel to the rocket. It carries fuel to take the rocket above the Earth's atmosphere. Right, so when stage 1, by the time stage 1 is emptied, the rocket is above the Earth's atmosphere. What does that mean? The main thing that you need to know about that, it means that above the Earth's atmosphere, there is no more air. Okay, it is a vacuum. So that means that later when you're explaining the motion of stage 1 for part B, you cannot talk about air resistance anymore because there's no air resistance above the atmosphere. Okay, so at a height of 67 km above the Earth's surface, stage 1 has no more fuel and detaches from the rest of the rocket. At this height, it has a mass of this and a speed of this. Okay, so this speed, what direction is this speed moving? It's moving upwards at this speed of 2.3 km per second. That's really, really fast, right? So after stage 1 detaches, it continues to rise. So we're looking at the rocket, it reaches here, and then say stage 1 detaches off above the Earth's atmosphere, and it's going to continue to go up, right? Okay, sorry, not the best drawing, but yeah, it detaches and it continues to go up, but its speed decreases. So explain why the speed decreases. Alright, so since I have the answer already given to you, I'm not going to slowly write the answer. Instead, I'm going to explain to you the thought process behind constructing an answer. Okay, and answer this question. So whenever you're talking about explaining, whenever you are explaining motion, so explaining why something decreases or explain speed decreases, why it accelerates, why it slows down, blah 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 blah. When you're explaining in terms of forces, you always want to be thinking about this chain of logic, this golden chain of logic that comes, of course, from what we discussed earlier. So the first thing you need to ask yourself is what are the forces acting on the object? Okay, and in this first question that you asked, you want to be specific about it, because this should contextualize your answer to the question. Okay, so it contextualizes your answer to the question. To the specific question itself by saying the specific forces that are acting on the object. So you ask yourself first, what are the forces acting on the object? Why do you ask yourself that? Because next you want to find out what is the resultant force. Why? Because after you know what the force acting on the object, then you know what's the resultant force, then you will be able to tell what is the acceleration. And when you know what is acceleration, you can describe the motion of basically you can say the change in motion. Okay, so often the question the question can be phrased two ways, right? So this is the golden chain that you need to know, right? So the question can be phrased, sometimes the question will give you this first. It will give you the change in motion. So for example, in this question, they tell you that the speed decreases, then they ask you to explain, right? So really in your reasoning, you can work backwards and then you explain from this to this to this to this, right? Sometimes they give you the forces acting on the object and they ask you to predict how it will be moving. It's the same chain. So they give you the forces, so what's the resultant force, so what's the acceleration, so what's the change. Okay, so this is the key flow here, which I'm going to walk you through the answer here to show you how this works. So explain why stage 1 decreases. So firstly, what are the forces acting on the object when stage 1 is detached? Right, so when it's detached, there is no air resistance because it's above the atmosphere. So the only force acting on stage 1 is its weight. Right, so this contextualizes the question. And so if the only force, so this is the first point, right? If the only force acting on its weight, what is its resultant force? The resultant force will be downwards at the value of its weight, right? So its weight is actually the resultant force. So it experiences a downward resultant force. And then acceleration, right? So this will really cause it to, it's going to decelerate, or it's going to, yeah, so downward resultant force causes either, if you're a stationary object, you accelerate downwards, right? But the significant part, the special part of this question is that actually the object is currently moving upwards. So the object is moving upwards, but there is a force downwards only, so it is going to decelerate. So since it is moving upwards, this causes it to decelerate, hence decreasing its speed. So this part here is actually, since it is moving upwards, this causes it to decelerate. I'm talking about the acceleration. And then this next part here, hence decreasing its speed, is talking about the change in motion, which is what the question, answering the question in this case. Okay, so this is the structure of the answer. I hope you can see that. What are the forces? Resultant force, acceleration, and change in motion. Okay, we're going to see in a short while that that is exactly what the next question is going to look like as well. Okay, so let's move on to part C. I'm going to move this chain down with me. Okay, so part C is a similar type of question. They give you a graph and then to show its motion. They tell you that the force due to friction of an object falling in air increases as the object's speed increases. So as the speed increases, the friction increases. So now we're talking about its fall. You see the stem of the question here. Stage 1 of the rocket then falls back into the Earth. Right, so now we're talking about the stage 1 has entered into the Earth's atmosphere. And this is what it looks like. So the vertical speed, the force due to friction on an object falling increases. So describe how the acceleration of stage 1 varies. So you're going to describe the motion, right? Can you see this? Describe the motion, describe how the acceleration of stage 1 varies as it falls towards Earth with reference to the forces acting on stage 1. Okay, so what do you do again? Again, it's the same kind of structure. Okay, but now you need to describe the acceleration as well from the graph. Okay, so there are two main phases in this acceleration. The first phase is here, and the second phase is here, isn't it? Right? So how do you describe acceleration? So this is a speed time graph. The acceleration is given by the gradient. So the gradient here, as you walk from left to right, how is the steepness changing? It is getting less and less steep, correct? So the gradient is getting less and less steep. That means the acceleration is decreasing. Okay, so you can so this part, the acceleration is decreasing. You can either say it's a decreasing acceleration, or what I usually tell my classes is from here to here, the speed is increasing, but it's increasing at a decreasing rate because it's getting less and less steep. Right, so you see from 0, the speed is going up. So the speed, this portion here, the speed is increasing. So always, is the speed increasing, decreasing, or constant? And then at what rate? So the first part is always, is the speed increasing, decreasing, or constant? Second part, at what rate? At a decreasing rate, because the gradient is getting smaller. Alright, and then this part here, same thing, ask yourself, is the speed increasing, decreasing, or constant? So the speed is constant. Once it's constant, there's no at what rate because the speed is just constant. Okay, so this is describing, but they ask you in this question, they ask you to describe how the acceleration changes. So the acceleration here actually is 0, right? There's no change in acceleration, and down here, the acceleration is decreasing. Okay, so for this specific question, you need to talk about the acceleration because they ask you specifically about the acceleration. Okay, so let's see how we form the answer there with the unit of the forces. So we need to explain these two parts and explain in terms of the forces why it's like that. So it falls down towards the Earth from rest. It accelerates due to its weight. So we're talking about this initial accelerating is getting faster and faster, right? So it's accelerating. This causes it to experience an increasing amount of friction, which acts upwards. This was given by the question. So we're now talking about what are the forces acting on the object, right? So we know that as it falls, its weight is pulling it down, but the faster it gets, the more and more the air resistance grows, right? So the air resistance is growing more and more as it gets faster. So what does this, so these are the forces acting on the object. I've identified the forces acting on the object, weight, and a growing air resistance. So what does this result in? The resultant force, right? That means that the resultant force is downwards, right? Because at first the air resistance is small, but it's growing more and more. So so the resultant force is downwards, but it is decreasing, right? So this part here, I've talked about what are the forces acting on the object, right? Then after that, I'm going to talk about the resultant force. So this results in a decreasing downward resultant force, right? The downward resultant force is getting less and less. And so if the resultant force is decreasing, the acceleration is decreasing. Okay, so then I've explained my acceleration, right? It is accelerating, but the acceleration is decreasing. So I've explained the first part of the graph. All right, let's explain the next part of the graph. So the next part of the graph, again, I want to ask what are the forces acting on the object. And now in the next part, why is there no acceleration? Because eventually it reaches a point where F air, the air resistance, is equal to the weight. And when it's equal to the weight, what will happen to the resultant force? There's no resultant force. Forces are balanced. Forces are balanced, there's no acceleration. There's no acceleration, its speed will be constant. Right? So do you see how this works? So as it continues to speed up, the upward force of friction will eventually be equal to its weight. So I'm explaining in terms of the forces acting on the object. From here, I conclude that there will be no resultant force. And so acceleration, no acceleration. Okay? And constant speed. But this question, they only ask you to explain acceleration. So I hope this has been helpful in thinking about how to think about your answers, how to phrase your answers. Always remember this chain. Okay, what are the forces acting on the object? So what is the resultant force? So what is acceleration? And if necessary, so what is the change in motion? Hope this helps.